Hello, here we are, day 2 of inference. What we're going to look at today are confidence intervals. So let's get the idea. A confidence interval has two parts. One, an interval calculated from the data. So we're going to get numbers. And remember, you don't have to print this out. You can just write it down and feel free to pause me if I'm going a little fast because mine is printed. Okay, so the first thing we're going to do, what did I spell? Calculated. I don't know what I was saying. Okay, calculated from the data. So we're going to get some numbers. And number 2, we're going to write a confidence interval in a sentence form. Okay, we're also going to have a confidence level. So a confidence level which gives the probability that the interval will capture the true parameter in repeated test samples. Repeated test samples. Okay, so we want to know. It asks the question, right? Our major question is, what would happen if we repeated the sampling many times? Okay, on the one I asked you to look at last time, we looked at 95%, which is very common, but I want you to have this level list, confidence levels, if we decide we want to be more or less confident than 95%, and that'll make sense once we do a problem. So confidence interval for a population proportion is this formula right here. So again, add this to the one you used yesterday. Right? I would make an index card with these on there. Okay, and basically, if you notice what we did, was it yesterday? Anyway, if you look at it, this part right here is the margin of error. We got to go way back to earlier in the year, but we're basically saying p hat plus or minus the margin of error. Okay. So, example, of the students who have a phone, 392 out of 500 have an iPhone. Find the following confidence intervals for the true proportion of students who have an iPhone. So we sampled 500 students. So of course, what is that? That's our N. That's how many out of 500, right? 392 answered yes, so the 392 is X. So we're asking, we have a sample of 500 students, 392 told us, oh, we have an iPhone. So what is P hat? P hat is going to be 392 over 500, which equals 0.784. So hopefully that makes sense from yesterday where we really didn't have the numbers. Now what we want to do is find a 90% confidence level. Find a 95, find a 99, and we're just practicing. So all we do is take p hat, which we now know, which is 0.784, right? And we plus or minus. Now we want 90, so we go over here and look up 90, and 90 has a 1.64, right? Times, I'm going to switch colors. Actually, I want to make sure you knew where to find that. Okay, and then we'll have our square root, and it's p. P is 0.784, correct? It's going to match. We already have that out here, p hat. And now what are we going to put? What is 1 minus 0.784? 0.216. Remember, these two numbers right here are going to add up to 1. So if we know 0.784, then we know this one. And what goes on the bottom here? 500. Okay, so let's look at, I'll let you type that in a minute. You can pause me. 95% is going to be 0.784 plus or minus. Now we'll go to 95, and 95 is 1.96. And remember, that's the most common. If it's not specified, if I just say confidence level and I didn't specify 90% or 99, you would always pick 95. This is going to be the same. And then we'll have a 99. So that's 0.784 plus or minus. We'll go look up 99%, and that's 2.58 times the square root p hat So pause this video for a second and plug those in. And remember, it's this number plus that, and then it's this number minus that. And you see if you get what I got, okay? So pause it. I'll see you in a minute. Okay, good, you're back. Let's see if you got what I got. 0.7538, 0.8142. And on this one, we got 0.7479, 0.8201. And on this one, oh, I didn't type that one in yet. Oh, yes, I did. There we go. 0.7365, 0.8315. Notice what happened to the numbers. Okay. 90 is smaller than 95, which is smaller than 99. Notice 90 is 0.75 to 0.81. Here we're 0.74, which is smaller, to 0.82, which is bigger. Then we go 0.73 to 0.83, excuse me. So this is a huge, huge, huge thing for you to realize, is that as we go smaller, our numbers get what happens? 75 to 81, right? 74 to 82. So it's like I moved out. 73 to 83. So the distance between these numbers gets bigger. So as you move up and you want to say I'm 99% confident, you get wider here because you, and we'll look at that in just a second. So let's interpret the 95% confidence interval. There's kind of a scripted sentence that goes with that. You know how in stats we always have to write things. So what we would say is we are 95% confident that the true proportion, and yes, your sentences must look like this, so write this out with me. The true proportion of students who have an iPhone is contained in the interval or is between, whichever way you want to say that, 74.79% and 82.01%. Okay, notice that's going to change and that's going to change, but the rest of the sentence, like if I were asking you about Nike shoes or whatever, this could change, and then of course depending on which question I ask you. So we are 95, let's think about what this says. We are 95% confident that the true proportion of students who have an iPhone is somewhere between 74 and 82%, really 75 and 82%, right? We came up with 78.4%, and we're saying, yeah, it's between here because we need a little wiggle room. Notice as you go up, like to 99%, you need more wiggle room. If I'm going to say 99% confident, then I'm going from 74 to 83%. So the bigger your percent, the higher your confidence level, then the wider spread out, the more wiggle room, if you will, that you have to get, that you give yourself. Okay, so interpret your 95% confidence level. I want you to notice the big difference here, interval, level. You can be asked that question. You want to know what the difference is, and what we would say here is that we obtain this interval, and you do kind of need to learn how to write these sentences pretty much exactly like I am, or something similar, but they have to be kind of fancy. You can't just write the numbers down. You got to have the words to go with it. It's statistics. We obtain this interval by using a method that catches the true unknown population proportion in 95% of all samples. Okay, so you need to know how to write an interval and how to write a level, and think about it. We obtain this interval by using a method that catches the true unknown population proportion in 95% of all samples. This is the part that will change from problem to problem. If we decided to go with this one, it'd be 95%. But remember, as you increase your confidence level, okay, as you go up to 99%, you get a little bit wider. So you're not saying that we think it's between 75 and 82. If we went down here, we'd say, well, it could be between 74 and 83. So you are widening where you're accepting. So watch that. Another survey found that 77% of 6,574 adults surveyed have an iPhone. How many people in that survey have an iPhone? Well, This is an easy problem, but sometimes we forget how to do it. It says 77% of 6,574 adults have an iPhone. How many have an iPhone? Well, I got 6574 times 0.77, so 5,062 people surveyed. Remember, we have to write nice sentences in statistics. And like I said, just as you increase, remember you have a wider confidence level as you go up, okay? And remember, these results, like with iPhones, could change depending on where you live. In our area, we know we have a lot of iPhones. Well, that's it for today. So you are ready to do your first homework assignment, part of the first homework assignment. So what you're going to do is all of page 5 and page 6. But you know what? I think we need a few more notes before. So what you're going to do is page 5 and page 6 to right here. And we'll do the rest of this homework assignment when we have a few more notes, okay? Have a great day and visit me on Zoom if you have any questions. Bye-bye.